Welcome to the second week with me in our Science 102. This is a brief video that will both serve as an introduction to the week's content and also as a review towards the end of the week. Most importantly this week, we're going to be talking about atmospheric composition, global and local atmospheric circulation, and then, if all goes well, the hydrologic cycle. So let's get started. First of all, in this video, again, what I'm going to be doing this week is we're going to be talking about these main themes. And for your notes and for preparation for the next content exam, focus on these three pieces. So first of all, we're going to talk about atmospheric structure and its composition. The atmosphere has a vertical structure to it. We're then going to briefly discuss the natural composition of the atmosphere and how humans contribute to it. And then once we've gone through kind of the atmosphere as a physical thing, we're then going to talk about its dynamics. And in that, we're going to talk about vertical characteristics of the atmosphere in terms of how localized heating and vertical movement occur. We're going to talk about how that perhaps relates to our local weather. And then we're going to be talking about how circulation in the atmosphere occurs. And most importantly, we're going to understand it in the context of energy transfers and perhaps how you experience as winds. Lastly, this week and beginning into next week, we will be talking about the hydrologic cycle, and that is how we understand water on Earth. Now, if we look at the major components that we're going to be talking about this week, what I want you to be able to do at the end is talk a little bit about, for example, in this map of the United States, how winds might relate to areas of low pressure and areas of high pressure. Also, what we mean by the movement of air and the idea of areas of warm air versus cold air, and how those areas might come into existence and what they might do in terms of our local weather. We're also going to be talking about the vertical structure of the air and why, in this case, why temperature, this line represents temperature. As we go up in altitude, why does temperature go down? Then why does it stay relatively stable, then begin to increase as we move in this direction, and then again stay relatively stable, and then begin to go back, and then the other direction. So we want to understand why that happens. We're going to learn some new units, most notably the hectopascal or millibar, their equivalent, and what pressure really means in our atmosphere. We're going to talk about atmospheric heating and circulation. In other words, here's our, from last week, energy into the system. This is the distribution of net or absorbed shortwave radiation, and it changes throughout the seasons. What we're also going to see then is that we have surpluses and deficits, and if that's the case, how do things equilibrate? How do they become even? We're going to be talking about something called lapse rates. And these have to do with local atmospheric conditions, a little bit about how moisture in the atmosphere relates to energy in the atmosphere. We're going to talk about the big picture, circulation systems on Earth, and how these circulation systems work to equilibrate energy in the system. We're going to talk about what causes air movement at a global and regional level. And then we're going to be talking about the hydrologic cycle. And in this case, what we're looking at is rain. This is monthly precipitation on average in millimeters. And so we're going to talk about, you'll notice that these patterns look remarkably similar to energies in the system. And we're going to be talking about those relationships and how water and energy into the system and the movement of energy interact. So that's it for our brief introduction. Please make sure that you look back at this slide and are able to answer these questions by the time the exam comes along.